Hello, students. Let's talk about statistics and probability concepts. Let's take a look about agenda or learning objective. In this module, we have to first of all talk about statistics, like introduction to statistics. What is the meaning behind the statistics? Then we have to discuss about statistical analysis consideration. In particular, that we have to find out some basic terminology in field of the statistics, population and sample, and many more things are there. After that, in a statistical analysis process, we have to find out some data distribution, normal distribution, and many more measure of central tendency like that one. And then we have to find out two types of the statistics like inferential statistics and descriptive statistics. So first thing that is the introduction to statistics. So let's start it with the what is the meaning behind the statistics. Statistics is the study of the collection, analysis, interpretation, presentations, and organization of the data. So basically, statistics is an area of applied mathematics concerned with the data collection, analysis, interpretation, and the presentations. This area of the mathematics deals with understanding how data can be used to solve complex problems. Here are a couple of example problems that can be solved by using statistics. Like your company has created a new drug that may cure cancer. So how would you conduct a test to confirm the drug will be effectiveness? Second example, you and your friend are at a baseball game, and out of the blue he offers you a bet that neither team will hit a home run in that game. Should you take that bet or not? So that is a question mark is there. So the latest sales of the company, like the sales data, have just come in, and your boss wants you to prepare a report for management on places where the company could improve its business. What should you look for that, and what should you not look for that one? So there is a multiple type of situations are there, and according to that situation, we have to implement the statistical knowledge in terms of the analysis, interpretation, presentations, and organization for particular data. In the statistics, let's talk about some of the more thing related to that one, like tools available for the analyzing the data. So like statistical principles are there, functions are there, algorithms are there. So what you can do using as a statistical tool as well as so analyzing the primary data whenever the statistics are there, building a statistical model is there, as well as predict the future outcome. So whenever we are talking about the statistics, so in outcome of statistics we want this type of thing. Okay, first of all, what are the data will exist, we have to do some analysis based upon that, and we are trying to predict the future outcome as well as. Let's talk about some more information about the introduction to statistics part. So that's why let's go with the statistical analysis and non-statistical analysis. So statistical analysis is the science of collecting data and uncovering the patterns and trends. It's really just another way of saying statistics. After collecting data, you can analyze it or summarize the data. For example, make a pie chart. Also, statistical analysis is considered as a scientific, and it is based upon a number or statistical values, and it will useful in providing complete insight to the data. If we talk about a non-statistical analysis is based on very generic information exclusive of statistical or quantitative things. Although both form of the analysis provide results, quantitative analysis provides more insight and a clear picture about this one. And this is why statistical analysis is important for the business as well as. Same domain in introduction to statistics, or if you can go with the very deep with it with the statistics, let's talk about some of the major categories of statistics. The field of statistics is divided into two major divisions. Descriptive statistics are the essential, inferential statistics are there. Each of these segments is important and offering different techniques that accomplish different objectives. Descriptive statistics describe what is going on a population or a data set. Inferential state analytics use the probability theory to arrive at a conclusion. Random sample is drawn from the population and it uses to describe and make inference about the population. So that type of thing are working over here in major categories of the statistics. Inferential analytics is valuable when it is not possible to examining each member of the population. So that's why it is again important part of the things. Continue with the major category of statistics. We have to study of the height of the population. So here again we have to describe more about inferential method and descriptive method. At the end of this session we can also discuss more about these two methods, but currently here we are not going with the very depth of these methods. We are just taken overview of the inferential method and the descriptive method. So inferential statistics makes inference and prediction about a population based on a sample of data taken from the population in question. Inferential statistics generalize a large data set and applies probability to draw a conclusion, and it allows us to infer data parameters based on a statistical model using the sample data. So, if we consider the same example of finding the average shirt size of student in a class, in inferential statistics, you will take a sample set of the class, which is basically a few people from the entire class. You already have had a group the class into the large, medium, and small things. So, in this method, you basically build a statistical model and expand it for the entire population in the class. Categorize heights as tall, medium, and short. Take a sample to study from the population. Second thing, that is the descriptive method. Descriptive statistics or descriptive method is a method used to describe and understand the features of a specific data set by giving short summaries about the sample and measures of the data. Descriptive statistics is mainly focused upon the main characteristic of the data, and it provides a graphical summary of the data. Suppose you want to gift all your classmate t-shirt to study the average of shirt size of student in a classroom. In descriptive statistics, you would record the shirt size of all the students in the class, and then you would find out the maximum, minimum, and average shirt size of the class. Record the height of the each and every person, provide the tallest, shortest, and average height of the population. So that's how we can find out the inferential method and the descriptive method. Let's take a look out about the statistical analysis consideration. So what type of consideration we have to take during the statistical analysis? So there is four type of analysis is mainly important. First one, that is the purpose. So clear and well defined purpose we have to create. Second one, that is the document questions. So prepare a questionnaire in advance. So whenever we are trying to do some statistical analysis, at the same time prepare a questionnaire. That is the important part. Third thing, that is the define population of interest. Select population based on the purpose of analysis. And the last one, that is the determine sample. So based on the purpose of study. So that's how we have to take on some statistical analysis consideration before statistical analysis. After discussing about this one, let's take a look about population and sample. So, what is the meaning of population? A collection or a set of individuals or objects or events whose properties are to be analyzed. That is called as a population. So, what is the meaning of sample? So, sample, it's a subset of the population is called sample. A well chosen sample will contain most of the information about a particular population parameter. Also, a population can consist of various of samples, and the samples together represent the population. A sample is the part or piece drawn from the population, the subset of the population, a random selection to represent the characteristic of the population, representative analysis of the entire population. So that's how we are getting idea about the population and samples. Let's take a discussion, some of the discussion based upon a statistics and parameter. Statistics are the quantitative values calculated from the samples, and the parameters are the characteristics of the population. So, here, based upon statistics and parameter, we are getting some three terminologies over here: mean, variance, and standard deviation. So, what is the meaning of mean, and what is the meaning of standard, and what is the meaning of variance, and what is the meaning of standard deviation? Already, population parameter sample statistics and formula is provided over here. But first of all, we have to find out what is the meaning of these all three. Mean, it means measure of the average of all the values in a sample, that is called as a mean. The variance is a measure of variability. It is calculated by taking the average of squared deviations from the mean. Variance tell you the degree of spread in your data set, and the more spread the data, the larger the variance is in relation to the mean. And the third thing, that is the standard deviation. So the standard deviation is a statistic that measures the dispersion of a data set relative to its mean, and it is calculated as the square root of the variance. If the data points are further from the mean, there is a higher deviation within the data set, thus the more spread out the data and the higher the standard deviation. So that's how mean, variance and standard deviation will give an idea. Let's talk about term used to describe data. So basically here we are working within typical terms used in data analysis are there. So there is search, inspect, characterize, and conclusion are there. So let's talk about this. First of all, this for parameter. Search is used to find the unusual data, like data head does not match the parameters. So that's why we are using a search. Typical term. Search is one type of typical term. Second typical term is inspect. So at the same time, inspect, we have to find something, or inspect refers to studying the shape and spread of the data, like how much vary the data and how much spread the data according to data set. Third thing, that is the characterize. Characterize refers to determining the central tendency of the data. And last term, that is the conclusion. So conclusion refers to preliminary or high level conclusion about the data. So that's why these are the typical terms are there. Also, as compared to these four terms, there is still many more terms are available. We have to find out like what are the terms are there. But now this session is completed over here. In the next session, we have to learn about some statistical analysis process. Let's talk about statistical analysis process. There are four steps into this statistical analysis process. Step one, it is coming with the find the population of interest that suits the purpose of the statistical analysis. Step number two will refer draw a random sample that represents the population. Step number three will represent compute sample statistics to describe the spread and shape of the data set. And step number four will refer make influences using the samples and calculation, apply it back to the population. So that's how within this four step of process, statistical analysis should be done. But it is not just simply done within these four steps, but within these four steps, we have to do many more things based upon population, sample, and also we have to find out some of the data distribution. So let's talk about data distribution. The distribution is a mathematical function that describes the relationship of observations of different heights. A distribution is simply a collection of data or scores on a variable. Usually, these scores are arranged in order from smallest to largest, and then they can be presented graphically. The collection of data values arranged in a sequence according to their relative frequency and occurrence. The range of the data refers to minimum and maximum values. It is the given measure of how spread apart the values in a data set are, and the range can be calculated as particular in the equation of range is equals to maximum of the input side, maximum of the input side, subtract with the minimum of input sides. So range of the data refers to minimum and maximum values. So that is the what are the subtraction can be happen in between the maximum value of x and the minimum value of x. And then when we talk about the frequency is indicates the number of occurrence of a data value, and the third thing, that is the central tendency, that will indicate data accumulation towards the middle of the distribution or towards the end. In statistics, a central tendency is a central or typical value for a probability distribution. It may also called a center or location of the distribution. So co-equally measure of central tendency are often called the averages as well as. So let's talk about the measure of central tendency. When we talk about the measure of central tendency, so again three important things will generate over here like mean, median and mode. Previous session we already talked about what is the meaning behind the mean, but still we have to talk about what is the meaning behind the median. So let's talk about the measure of central tendency. Measure of the center are the statistical measure that represent the summary of a data set. There are three main measures of centers are there: mean, median, and mode. So first thing, that is the mean. Measure of the average of all the values in a sample particular, that is called as a mean. So that's how mean should define earlier as well. So here, if you can see this example, so here we are having some nine values. So according to the nine values, we have to simple take an average of these nine values. So at the same time, we are getting mean of this particular sample. Second thing, that is the median measure of the central value of the sample set, that is called as a median. So here, what are the middle number is there? We have to arrange everything in terms of the ascending order to descending order, and according to the ascending order, and according to the ascending order, we have to find out the middle number. So that is known as a median. And the last thing, that is the no mode. Mode is the most frequent value. So the most frequent or recurrent in the sample set, that is known as a mode. So here, if you can see, the 3 times 80 what it will be exists. So that's why 80 was be a mode. So that's how measure of central tendency should be worked. Next, we have to see about percentile in a data distribution. So what is the meaning behind the percentile, as well as what is the meaning behind the first quartile, second quartile or median, and the third quartile. A percentile or a centile indicates the value below which given percentage of the observation fall. So if you can see over here, the quartiles tell us about the spread of a data set by breaking the data set into quarters, just like the median breaks it in half. Also here we have to more discuss about the what is the meaning behind the first quartile, second quartile, and the third quartile. So first quartile, it refers the lowest 25 percentage of the number. Second quartile, it will refer the 25.1 percentage and 50 percentage of number. And third quartile, it will represent the 51 percentage and 51 percentage to 75 percentage of the numbers. So that's how we can understand about the first quartile, second quartile, or the median, and then third quartile. So after getting idea about the percentile and data distribution, next we have to say about the dispersion. Dispersion denotes how stretched or squeezed distribution is that. So the dispersion is a statistical term that describes the size of the distribution of value expected for a particular variable. Dispersion can be measured by several different statistics such as range, variance, and standard deviation. So let's talk about some of the things related to the range. Already we talked about like range is the difference between maximum value of x and the minimum value of x, like particular feature. Interquartile range, that is the difference between the 25th and 75th percentile. It is also known as difference between first quartile and third quartile. Variance, data values around the means, and the standard deviation, square root of the variance measured in small units. So that's how we are getting some of the parameter from the dispersion size. So let's talk about to bell curve or the normal distribution. It is again one of the most important statistics concept, that is a bell curve or the normal distribution. The bell curve is characterized by its bell shape and two parameters, mean and standard deviation. A bell curve is a common type of distribution for a variable, also known as the normal distribution. The term bell curve organized or the it's organized like from the fact that the graph used to despite a normal distribution consists of a symmetrical bell-shaped curve. The highest point on the curve or the top of the bell represent the most probable event in a series of data. For example, its mean, median, or mode in this particular case. So while all other possible occurrences are symmetrically distributed around the mean, creating a downward sloping curve on each side of the peak. The width of the bell curve is described by its standard deviation. So that's how bell curve should be made. Also, the bell curve is symmetric around the mean. It is also symmetric on both sides of the center, having equal mean, median, and mode values are there. Denser in the center and less dense in the tails or sides, defined by mean and standard deviation, and it is also known as the Gaussian curve. So because the shape is look like a Gaussian, so that's why it is all much popular with the Gaussian curve as well as. And whenever we should learn about the bell curve, so at the same time I was thinking you have to take in some key takeaways. Like a bell curve is a graph like a depicting the normal distribution, which has a shape of a reminiscent of a bell, and the top of the curve shows the mean, mode, median of the data collected. Its standard deviation depicts the bell curve's relative width around the mean. Also, bell curve are used commonly in statistics, including in analyzing economic and financial data. So that are some of the important key takeaways are there. I hope you have to taken this type of normal distribution related key takeaways. Still, we have to talk about some of the more important thing related to the bell curve, and that is based upon a left skewed and right skewed. First of all, we have to discuss about what is the importance of left skewed. So skewed data distribution indicates the tendency of the data distribution to be more spread out on one side. Okay, so at the same time we are getting an idea like one side it will more spread. Okay, so a normal curve, left skewed curve or the left skewed distribution has a long left tail. So left skewed distribution are also called as a negatively skewed distribution. That's because there is a long tail in the negative direction on the number line. So that's why data is left skewed. So mean is less than median, and the distribution is negatively skewed, and left tail contains larger distribution. So if you can see left hand side you are getting some more information like more examples are there, and right hand side there is so there is a low measurement is like a very less is there, but frequency is very high on a left side, on a right side. Okay, so that's why it's a left skewed is there. Similarly, opposite thing we are find out in the right skewed bell curve. So the right skewed distribution are also called as a positive skew distribution. That's because there is a long tail in positive direction on the number line, and the mean is also to the right of the peak, and the normal distribution is the most common distribution you will come across. So skewed data distribution indicates the tendency of data distribution to be more spread out on one side. So the data is right skewed, so at the same time the distribution is positively skewed. Mean is greater than median. In a last situation mean is less than median, but here mean is greater than median. Right tail contains large distribution. So this type of stuff we are getting over here in a right skewed bell curve. So here normal distribution should be over to complete to over here. In the next session we have to talk about like how kurtosis should be worked over there. Let's talk about the kurtosis. So, what is the meaning of kurtosis and what is the type of kurtosis? And we have to take in some brief discussion about kurtosis. Kurtosis is a statistical measure that is used to describe distribution, whereas skewness differentiate extreme values in one versus the other tail, and kurtosis measures extreme values in either tail. Distribution with large kurtosis exhibits tail data exceeding the tails of the normal distribution, for example, 5 or more standard deviation from the mean. Distribution with low kurtosis exhibits tail data that are generally less extreme than the tails of the normal distribution. Kurtosis describe the shape of the probability distribution. Also, kurtosis measures the tendency of the data towards the center or towards the tail. So basically, three types of kurtosis are available. Platykurtic is negative kurtosis. Mesokurtic represent a normal distribution curve, and the third one is the leptokurtic is a positive kurtosis. But now we have to discuss a brief in this type of the kurtosis. There are basically three kurtoses of the categories of kurtosis that can be displayed by a set of data, and all measure of kurtosis are compared against a standard normal distribution or a bell curve that we already completed in a last session. The first category of the kurtosis is a mesokurtic distribution. This distribution has a kurtosis statistic similar to that of the normal distribution, meaning the extreme value characteristic of the distribution is similarly to that of a normal distribution. The second category is a leptokurtic distribution. Any distribution that is leptokurtic displays greater kurtosis than a mesokurtic distribution. Characteristic of this distribution is one with long tail, and the prefix of lepto means skinny, making the shape of the leptokurtic distribution easier to remember. The skewness of the leptokurtic distribution is a consequence of outliers which stretch the horizontal axis of the histogram graph and making the bulk of the data appear in a narrow vertical range. And the final type of the distribution is a plekurtic distribution. This type of the distribution have a short tail like paucity of the outliers. The prefix of the platy means broad, and it is meant to describe a short and broad looking peak, but this is an historical error. So that type of thing we are finding out during the kurtosis. After talking about the kurtosis, now it's time to talk about the three types of the variable. So basically, we are having normal variable, ordinal variable, and the association variable. So first of all, let's start with the nominal variable. A nominal variable is a type of variable that is used to name, label, or categorize particular attributes that are being measured. It takes qualitative values representing different categories, and there is no string ordering of these categories. Some example of nominal variables include gender, name, phone, and etc. Values with no logical ordering. Variables are independent of each other and sequence does not matter. Second parameter or second variable, that is the ordinal variable. Ordinal data is categorical statistical data type where the variables have a natural ordered categories and the distance between the categories is not known. Values are in a logical order and the relative distance between two data values is not clear. So that's how ordinal variable should work. And the last type of variable, that is the association. Association between two variables means the values of one variable relate in some way to values of the other. So association is usually measured by correlation for two continuous variables and by cross tabulation and chi-square test for the two categorical variables. So two variables are associated or independent of each other. So that should come within a association variables. In the next session, we have to learn about correlation matrix. Now let's discuss about correlation matrix. A correlation matrix is simply a table which displays the correlation coefficient for different variables. The matrix depicts the correlation between all the possible pairs of value in a table. It is a powerful tool to summarize a large data set and to identify and visualize pattern in the given data. Correlation matrix consists of rows and columns that shows the variables. Each cell in a table can contain the correlation coefficient. In addition, the correlation matrix is frequently utilized in conjunction with other types of statistical analysis. For instance, it may be helpful in the analysis of multiple linear regression models. Remember that the models contain several independent variables in multiple linear regression. The correlation matrix determines the correlation coefficient between independent variables in a model. So, a correlation matrix is a square matrix that compares a large number of variables. So, correlation matrix is a square matrix. It will come within n cross n matrix. Very large number of rows and columns are there. Correlation coefficient measures the extent to which two variables tend to change together, and the coefficient describes both strengths and direction of the relationship. So, particularly in with the correlation matrix is a square matrix that compares a large number of variables. So, there is two things are available over here. So, Pearson product moment correlation are there, and second one is the Spearman rank order correlation are there. In the particularly Pearson product moment correlation, it evaluates the linear relationship between two continuous variables. So the linear relationship means that a change in one variable result in a proportional change in other. If we can talk about the Spearman rank order correlation, it evaluates the monotonic relationship between two continuous or ordinal variables. It also consider within monotonic relationship means that the variable tends to change together through not necessarily at a constant rate, and the correlation coefficient is based on a ranked values for each variable rather than a raw data. So that's how things are working over here whenever we have to talk about the correlation matrix with the Pearson product moment correlation and the Spearman correlation, Spearman rank order correlation. So after talking about the correlation matrix, in the next things we have to take on some little bit again idea about the inferential statistics as well as the dispersion statistic. So let's taking some idea about the inferential statistics again and again. Again, we before in last session or before last session, we are just only getting about basic idea about the inferential statistics as well as this descriptive statistics. But now we are taking some more depth idea about the inferential statistics. So the inferential statistics uses a random sample from the data to make inferences about the population. Inferential statistics can be used only under the following condition, like a complete list of the member of population is available or a random sample has has been drawn from the population. Using a pre-established formula, you determine that the sample size is large enough. Inferential statistics can be used even if the data does not meet the criteria. It can help determine the strength of the relationship within the sample. If it is very difficult to obtain a population list and draw a random sample, do the best you can with that one. After discussing about the inference statistics, let's talk about some of the application based upon a inferential statistics. So if we can talk about the inference statistics application, so it has uses almost every field such as business, medicine, data science or data analytics, and many more things are there. So it is an effective tool for the forecasting, time-based forecasting or the weather type of forecasting. It is also used to predict the future pattern because forecasting is also coming in a part of the future patterns based upon that. So inferential statistics are often used to compare the difference between the treatment groups. Like inferential statistics use measurements from the sample of subjects in experiment to compare the treatment groups and make generalizations about the larger population of the subject. So that's how we can work with it application of the inferential statistics. So basically, in this particular module of statistics and probability, we have to first of all starting with the introduction to statistics. Then we can take an idea about the measure of central tendency. Then we can get an idea about the bell curve, normal distribution, right skewed, left skewed. After that, we can discuss about the kurtosis, and last we have to discuss about the correlation matrix. And again, we can wind up within inferential statistics. In this session, we have to see some coding based upon statistics and probability. So here, let's check it out some of the basics test. Okay, so that is also known as the normality test is there. So main objective of performing the normality test is to validate the Gaussian distribution data, because during the theory part we have to discuss about a normal distribution as well as data distribution, bell curve, how Gaussian distribution should be worked. Okay, so based upon that we have to see about the Shapiro-Wilk test as well as then a test whether a data sample has a Gaussian distributions are there. And for that we have to take on some type of the assumptions as well as like observation in each sample are independent and distributed identically. Okay. So let's first of all give some heading related to that one. Like we have to see in some normality test because that is important for us. That's why. And for that, we have to assume some of the hypotheses. Okay, like H0 and H1. So basically, with the H0, the sample has a Gaussian distribution, and whenever we have to talk about the hypothesis one, so it should look like the sample does not have a Gaussian distribution. Okay, so in one side we are having Gaussian distribution, in another side we are not having any type of the Gaussian distribution. So let's start the code with the library. Okay, so first of all, we have to see about the library, like which type of library should be helpful for us. So first library, that is the SciPy. Okay, but here we are not directly using NumPy pandas, but here we have to use SciPy library because the normality test should comes with the Shapiro-Wilk test. Okay, so we are having already the one of the algorithm based upon the Shapiro. Okay, so that's why from the SciPy dot states we have to use. Okay, so from the SciPy states we have to import a Shapiro, so they can recommend the things or not. Yes, now the Shapiro, yes, they can recommend after some time. Yeah, so we have to import the Shapiro over here. Okay, so after that one, we have to create first of all some data for that, and as well as we have to create some states for that one. So first we have to create a data. So we have to create a data parameter, and in that data we have to take in here data. In that, for that we have to create a list. So basically we have to take in some random numbers of data. Okay, so we have to take like 0.87, then we should take 2.18 as well as 0.121. I just taken some random data. Okay, that data is not fixed. Also we have to take in some negative data as well as like 0.94, like that. Also we are able to take 0.055. Okay, also let's take it 0.05 in terms of minus, so that should give some better idea like how the normality should work over there. Then minus 1.43. Also let's take it minus 1.66. Then we have to take an minus 1.89. So I think up to minus 2 we are having some values are there, okay, and that's better. So once we can create the data, then next in we have to take on some states over here. We have to take on state, and with that state we have to consider the p is equals to Shapiro. Like already we are having the algorithm for the Shapiro, okay, so that's why we do no need to take some more stress over there and Shapiro of data, so we are getting easily idea. And to get the output based upon a print function, so that we have to take on over here the state is equals to, also we have to take on curly brackets, and inside the curly brackets we have to fill some values, let's like 0 semicolon. With that we have to take on 3 in terms of the decimal over here. After we have to take on p is equals to, again same things we have to take on over here in terms of the decimal point over here. So once we can take on this one, so at the end we have to use the format function over here, and inside the format function we have to take on state as well as the value of p. The both the things we have to take on over here. Once we completed this one, then at the end we have to take on the if condition over here, like if p is greater than 0.05 with the semicolon. So again we are trying to print with the probability Gaussian, so that's why we have to take an probability Gaussian over here, and that should complete it over here. And at the end, we have to take on one else condition over here, and in that else condition, we have to put it some more thing related to the print. If this condition is not fulfilled, we have to get probability not Gaussian. So that is our hypothesis, nothing but a hypothesis. Like probability is not Gaussian. So that is the insight from that one. And now we have to run this code. So at the same time, we are getting an idea of state that is a 0.931, and the probability that should be a 0.931. So both are looks are similar over here. So that's why it's a probability Gaussian is there. So that is depends upon our data. If I can change again data, so again I'm getting some different type of stuff over here. So that is a basically normality test is there. With the normality test we can see about the Shapiro Wilk test, okay, so that is the one type of normality test is there. The second type of normality test, that is the D Agostino test is there. So D Agostino test is there. So that is again complex is there in terms of the normality, because again we have to create some states, and just we have to replace the normal test at the same time to get some Agostino test, okay. So let's see how to Agostino test should be work over here. For that the name is the D Agostino taste is there, okay, and it is not, it is also located as a normal taste. But before that, what we have to do, we have to copy this whole code over here from over here, because we are not trying to make it all the things newly, okay. Like as replacement of the Shapiro, we have to just only we have to take normal taste over here. Like normal taste we have to take on over here. Again, when we talk about the p is equals to Shapiro, at the same time again we have to design as a normal test over here, otherwise we no need to apply anything different over here. So again we have taken normal distribution, and now again we're trying to run this code. So at the same time, according to the D Agostino test, we are getting states is equals to 0.998. Similar probabilities there, and probabilities again Gaussian. So at the same time, the main concern, that is the probability is Gaussian or not. So that is the important things over here. After that the Agostino test, now we have to sing as we are now we have to sing Anderson Darling test, okay. So this test whether a data sample has a Gaussian distribution. So again we have to take in some assumptions like observations in each sample are independent and distributed identically. So that type of things we have to again evaluated over here. And again during the coding of this one, again we have to take in some two hypotheses, like the sample has a Gaussian distribution or sample does not have any type of the Gaussian distribution. So that type of things we have to evaluate it over here. So let's start it with the Anderson and Darling test. Okay, so that is also part of the statistics and probability. Again, we have to made it pasted over here the same thing like from SciPy test. At the same time, we imported the Shapiro, but now we have to simple imported the Anderson easily. Okay, also over here we have to just take an Anderson again over here. Okay, so we have taken Anderson of data, but the main thing is we have to change it over here. Like whenever we have to take an state is equals to 3 with the decimal point of f, here now we have to take an g. and we are not providing any type of the probability things over here, because here we don't want any type of the probability. Here we are just only working with the states. Okay, we are not working with the probability. So just a second, we have to end this bracket over here. Okay, yeah, now it's ended. And in this format of we have to just simply take states. Okay, so no need to take in this simple state. We have to take in some like result of statistics is there. Okay, and also here we have to remove this state as well as. Okay, so here it is known as simple result, because no need to work with the states, that's why. And here simply I have to take an result dot statistic over here. Okay, so that should end it over here. And here we have to provide one for range over here, like how it is in within for range it should work. So for a particular input sample we have to work, and in this particular input sample, within this input sample we have to take on some range. Range is also should comes within a length, and particularly in that length we have to again take on the critical things. Like with that we have to find out some critical values as well as, because that is again important thing is the like critical values. So after that we have to provide this semicolon over here, and then we have to just taken SL and CV over here, and similar thing I have to compare with the again result with the significance. Okay, so I have to taken, I have to find out for that one. Yeah, so that is a significance level. So significance level should comes within all the inputs. So that's why I do select the I, and as well as with the result with the critical values are there. So already we taken, yes. So that is the critical values. We just only wants values. Okay, again with the I or number of samples. Okay, and here we have to just simply change this condition, otherwise the thing is perfect. Okay, probability with the things, like if the results comes within some statistics are there. Okay, so it should follow the statistics. Okay, and it should less than the CV, that is again important part is there. Then we want to send like probability Gaussian at the particular probability Gaussian should be work at a particularly 1% of level. Okay, so that's why we have to complex. We have to write down the particular percentage of syntax as well as. So for that we have to take a percentage of one within some decimal points, and then again we have to take on that particular level over here, and then again we have to provide the percentage in terms of the SL. The same thing we had to done over here, like probability is not Gaussian. So what type of chances are there? It shouldn't be a Gaussian. So again, for that we have to use this same one over here. So I have to remove that one. So let's try to print this code, or yes, we are getting an error. Okay, so okay. So whenever we are using, yes, so that is not required. I forgot to remove that one. Also yes, for I in range is there, so at the same time result are coming with the critical values. Okay, so that should be correct, but why we are getting an error? We have to again check the code as well as. Okay, so it's one more spaces is there, that's why. Yes, now we are getting the perfect thing over here, like how it should worked over here in terms of the states, and as well as probability question at the 1% of level. It is also depends upon if you can provide some more input, so you are getting some more things. Okay, also in the statistics and probability, if you want to do, you can also do the some correlation tests are there, as well as the Spearman rank correlation are the Kendall's rank correlation are there. So many type of statistical tests are available with the statistics and probability concept. But basically, due to our course, I just want to discuss about this very little and very basic type of the statistics and probability type of test. So this session is ended over here.